Okay, everybody, this is our first example for paired samples from chapter 18. So if you'll notice, there's a few things that have to be given for paired samples. There needs to be two lists, either natural pairs or the same subject measured twice. And so this is going to end up being, when I say natural pairs or the same subject measured twice, I hope that we all notice that this is the same student recorded, and then there's a before and after score, whether we know what those represent or not yet. We're going to try to figure this out here, okay? So let's look at this together. A composition teacher wishes to see whether a new grammar program will reduce the number of grammatical errors her students make when writing a 2-page essay. The student scores are shown below. Using an alpha of 0.01, so I'll go ahead and record that here. It's a very small alpha level. Can it be concluded that the number of errors has been reduced using the new program? Okay. Write your hypotheses, perform the test, find the test statistic, the p-value, and state your conclusion. Okay, so first of all, we're trying to test if the number of errors was reduced. That's what we want to test, right? So what does that mean in the context of a score, right? If I have less errors in my assignment, then I actually have a higher score. So the after score will be larger than the before score because errors have been reduced. Now remember that if we're pairing our data, we will be looking at list 3 as list 1 minus list 2, which is before minus after. Okay? So if we take before and subtract after, but after was always larger, then we will expect for this difference to be negative. Okay? So let's say that again. If we subtract before from after, but after was always the bigger number to begin with, then our difference will always be negative. So I'm going to help set up these hypotheses because this is a new one, notation-wise. Okay? Now remember, because this is a difference test, the notation here is the difference. So this is the difference of the means, right? As opposed to, this is the mean of the differences, right? So we first find the differences and then calculate the mean of those values. We always assume that this difference is 0. And, I don't know why I put an equal to on the bottom. We always assume that the difference here is 0, like they wouldn't make any errors if the two groups are the same. And then we would also be using this notation right here that we just determined to help us find our alternative hypothesis. We just decided that if we are subtracting, the difference here actually has to be negative. So we would do the subtraction here of the two lists and make sure the difference is negative. Have a good day at work. Sorry to interrupt the video. So what we're really doing here is putting the data into the calculator and running a t-test on the data. So here are our steps. Step 1, put before in list 1, after in list 2, and then what we have to do is arrow up to highlight list 3. So like arrow over to list 3 and then go up and highlight it. And you'll notice that at the very bottom of your calculator screen, it says L3 equals. And you want to make sure that you set L3 equal to L1 minus L2. So that's second number 1 minus second number 2, if you forgot how to find those lists. Okay? Then, final step, we run a t-test on the differences, which is list 3. Okay? So I'm going to give you a moment to go ahead and do this work, okay? While you're doing that in the calculator, if you're struggling with that, there's two options. Remember that in the learning materials section of this chapter, there are videos to help you with calculator work, okay? And then I can also Zoom with you and show you on my calculator app how to do this. So what we want to do once we get to our, I'm still on the eraser tool here. Once we get to our t-test, okay, we're going to perform that t-test on data, right? And your list is going to be list 3. Let's do this in order. Mu naught is 0 in this case because we believe the difference is 0. The data is in list 3, and we are testing less than that mu naught. So when we go to our calculator and we get the output for this, we end up with t is negative 2.3658, and we get a p-value of 0.0321. And if you remember way back when we read the paragraph, we were asked to use an alpha level of 0.01, and 0.0321 is larger than 0.01. So we would fail to reject the null. And I'm going to take this space over here on the left side, and I know I'm running out of space here, but I wanted to give you some good notes for this first example. I'm going to take the space on the left to write that conclusion in context. So since we failed to reject, we now think there is not enough evidence to show, and then we're always trying to put the alternative hypothesis into words. So there's not enough evidence to show. And then what were we hoping to show? That the number of errors had been reduced, right? So there's not enough evidence to show the number of errors have been reduced using the new program. Let's be specific, because that's what they care about, is whether this new program, the grammar program, really helped these students. And it's clear from this data that unfortunately it did not. Okay. All right. I'm going to do that next example. If you want to, which is example 2 right below. If you want right now, you could go into your calculator and delete the data that's in list 1 and 2 and go ahead and put the data for example 2 in there. I am going to work through this one with you guys. Again, so if you struggle with the data entry, again, Zoom with me or watch my calculator videos that I found on YouTube under the learning materials page. Good luck, and I'll see you on the next video.